All right, so we're going to look at Chapter 3, Section 1, Measures of Central Tendency. Measures of center usually deal with finding the average. Average could refer to any one of these three values. It could refer to mean, median, or mode. You want to use mean for the average when you have numerical data. Those data should be resistant, which that means not affected by really, really big or small numbers. However, when you have numerical data that is affected by large or smaller values, then you want to use the median. And then when you have qualitative data, then you want to use the mode for your average. So we have some definitions of mean. When we start dealing with a little bit deeper statistics, we'll use this Greek symbol, which is pronounced mu. It's like a U with the extra tail. This is a symbol for population mean. When we do a sample mean, X bar is the symbol. It's an X with a bar above it. Do get familiar with those symbols. We will use those quite often. The way you find the mean is you add up all your numbers and divide by the total number that you have. So each individual value in this form is denoted by x1, x2, so on. And then this symbol here is summation, means to add all the terms up. So saying add up all the individual ones, it's just an index I. It's going to change based on how many numbers you have, and then you divide by the total. That will give you your mean. The calculation is the same for X bar. The only difference is the n. If we're using the lowercase n, that represents a sample. I'm using the uppercase n, that represents a population. Here's some sample data. Median. So we talk about how to find the median. You put all your numbers in order from smallest to largest or largest to smallest. And then you find the number of observations you have. If you have an odd number, then the median is going to be in the middle. If you have an even number, then you have to find the 2 in the middle and add and divide by 2. So if you have an odd, you can use this calculation, n plus 1 divided by 2. This will denote the position of the median. And then if you have an even number, then if you do n divided by 2, this is the position of the first number you use, and then you add 1 and you go to the next position, and those will be the 2 middle numbers that you would find the average of. And then we got some examples on finding the median. They're showing you those here, which we'll do some of this in MyMathLab. You can do it with technology, which we do have StatCrunch. So that's good to have those steps. That's integrated into MyMathLab or MyStatLab. We will be doing the descriptive statistics, finding 5-number summary, which I'll show you how to find all of this with the 84. So this term resistant, numerical data is said to be resistant if extreme observations very large or small relative to the data do not affect the value substantially. So familiar with that definition. Mean versus median. So they tell you mean is smaller than the median, that means the data is skewed to the left. If the mean is larger than the median, it's skewed to the right. If they're roughly equal, then it's symmetric. So this is kind of showing you what happens. So here's why they also call it skewed to the left and to the right. So if you have a lot of high data, and then you have some really, really small ones, not many, but some small ones, When you do the average, those small ones are going to pull the average to the left. That's why they call it skewed to the left. It talks about what's happening to the mean. And then if you have low values, say prices of some houses are not very high, but then you have one really, really expensive house in the neighborhood, when you do the average, because of the expensive house, it's going to move the mean to the right. It's going to make it look higher than what it should be. So really high or really low values are called extremes, and they will cause the median or the mean to move left and right. So you got some more data and information. So mode is the value that occurs the most. You can have more than one mode. You may have no mode. If all the data values occur the same frequency, then there will be no mode. So here's some other terms. Bimodal means you have two. Multimodal means you have more than two. And then here's a summary, just mean, median, mode. And that'll do for the intro.